Okay, it's time for us to start building our Arduino microcontroller project. For this project, we're going to be building a binary clock. Let's go over to the workbench and take a look at the materials that we're going to need for this project. Okay, here on the workbench, I've assembled the items that I'm going to need for this project. They are an Arduino microcontroller. It doesn't matter if you don't have this exact Arduino. Any Arduino will do. You will need a USB cable to connect the Arduino to your computer. We also have a breadboard. This is for placing our LEDs and wires. We have some wires, we have some LEDs, and we have a DS1307 real-time clock. The Arduino is going to be used to control LEDs to create a binary clock, and the DS1307 is going to be used to keep time. We could do this all with the Arduino, but we're going to get a much better, more accurate clock if we use the DS1307. All of these items can be purchased easily online. I suggest that you might go to adafruit.com and purchase them all from the Adafruit store. Okay, now that we know all the items that we're going to need, let's go ahead and put that aside. And let's talk a little bit about how a binary clock works. And by that, I mean let's talk about how binary works. We want to know how to read binary. So I have a little illustration here for you that will show us how to read binary. Okay, binary is really just, and you may have heard this, is just a series of on and off. It's either a 0 or a 1. 0 is off, and for our LED, that would be an off LED. Or 1 is on, and that would be a lit LED. When we take binary places and we string them together, we end up with multiple places, and we assign each one of those places a value. Let me show you on this next page. All right, so here's what we have. Our clock will actually be read from right to left instead of from left to right. Each place on each one of these LEDs is going to be either on, lit, or off, giving us either a 1 or a 0. Now, each place has a value, and they add together. So if I have, let's say for example, let's go ahead and write this out. You'll notice I have 5 LEDs at the top and 6 in each of the other rows. This will be our hours, and we're going to have a 24-hour clock. This will be minutes, and this will be seconds. All right, so let's say we have some arbitrary time. Let's say it's 1,300 hours. So we're going to say 8. We're going to turn this LED on. That'll be 8 plus 4. That's 12. And then plus 1. That's 13. So I have 3 lit LEDs. Each one is on, so it has a value of 1. But each place has its own value. So 1 plus 4 plus 8 will give us 13. For our next row, this will be the minutes, and it can go up to 60. We will have, let's say, 25. So we would first find something close to 25. We will start with 16, because we know that 16 is less than 25. 16 plus 8 is 24, so let's go ahead and mark in the 8. And now I just need one more for 25. So now we have 13, 25, and I don't know, let's give this a different number. Let's say 46 seconds. So we could say, all right, 32 plus 8 is 40, plus 4 is 44, plus 2 is 46. So now we have a time that is 13, 25, 46. And now we know the time. This is just a very brief overview of how binary clocks work and how binary is read. For further instructions, go to the website, download the instruction sheet, download the data sheets, and look at the web links for where to purchase your clock information. And I will see you on the workbench shortly.